Alright guys, so in this video we will discuss something very important. We're going to talk about the first 20 elements. We'll talk about their symbols, we'll talk about their mass numbers, then we'll talk about their charges. Alright, for most people, they can only read the first 20 elements. I mean, from hydrogen down to calcium, and that's wonderful. And they can also tell you the symbols. For example, hydrogen is H, helium is He, like that. Alright, and to some extent, they can also tell you the atomic numbers. But where the problem comes in is where they are asked about the charges and the mass numbers, and these are the two areas we're going to dwell on in this video. You already know what the mass numbers, what the atomic numbers are. For those of you who are still in limbo, the atomic numbers talks about the positional numbers of the element. For example, hydrogen is 1. Take the pointer right now. Hydrogen is 1, helium is 2, lithium is 3, beryllium is 4. So these, you see, are called the atomic numbers. So it means for you to remember the atomic numbers, you should be able to read the first 20 elements in the right order. This is helium, there's hydrogen, helium, lithium, all the way down to calcium. See, so when you read it in this order, you'll be able to get the atomic number with relative ease. Because if you want to get it, you just have to read it accordingly. So you're asked the atomic number of, let's say, boron. You have to read it hydrogen, helium, lithium, beryllium, boron. Then the atomic number for boron becomes 5. So this is the simple way to get the atomic numbers. So that's clear. Next, the next now we address right now is the symbols. The symbols rather. These in bracket you see are the symbols of the elements. So they're also important because in some of your chemistry exam, you may not see the full name written per se, but you will see the symbol abbreviated like this. So it means it is imperative that you know not only the element, but also the symbols. For example, the symbol for hydrogen is H, the symbol for helium is He, the symbol for lithium is Li, the symbol for beryllium is Be, boron is B, carbon is C, nitrogen is N, oxygen is O, fluorine, that's F, neon, that's Na, sodium, that's Na, magnesium, that's Mg, aluminum, that's Al, silicon, that's Si, phosphorus, that's P, sulfur, that's S, chlorine, that's Cl, argon, that's Ar, potassium, that's K, calcium, that's Ca. So these are the symbols for the first 20. So please commit those to memory. But the most important parts I want to emphasize in this particular video are the charges, like I said earlier, and the mass number. So I'll begin with the charges. How do you get the charges? How can you get the charges? The charges they're not something you cram. You don't memorize the charges. You have to know, because I always teach my students to understand and not to memorize, not to cram. Now, the charges are gotten by the position of the element, like the groups. The groups should give you the charges. For example, elements in group 1 have a +1 charge. Elements in group 2 possess a +2 charge. Elements in group 3 possess a +3 charge. Okay, now let's go on. Elements in group 4 possess a +4 charge. Third, +4, or it can be +2 as well, so it varies. Elements in group 5 do not possess a +5 charge. Instead, they possess a -3 charge. Third, elements in group 6 possess a -2 charge. Elements in group 7 possess a -1 charge. Elements in group 8 possess no charge. They are inert, so their charges are 0. Now you see this, right? According to the groups we give you the charges, then this is where you need the help of your periodic table. Now, suppose we want to tell the charge for hydrogen from the periodic table. hydrogen belongs to group 1. So if you know you don't have that, we'll create a different video on the periodic table, or if you have a sample in front of you, you can use that to follow up. But if you don't, we sure create a video on that periodic table. So hydrogen belongs to what group? Hydrogen belongs to the group 1. So it must possess, or it will possess, a plus 1 charge. Then helium belongs to group 8, not group 2, group 8. Group 8 are called the noble gases. We can also call them the inert or the rare gases. So it means they are unreactive, and so they possess no charge. So the charge for helium is 0. So you won't see helium possessing any charge. So helium is 0. Now the charge for lithium. Lithium also belongs to group 1, and since it belongs to group 1, it possesses a plus 1 charge. So it belongs to the same group with hydrogen, which is group 1. So like I said, I don't want to digress too much into the periodic table because I feel enticed right now to talk about the periodic table. So I'll save that for a different video entirely. Now let me erase this so I can have some space here. Alright. Beryllium. Beryllium belongs to what group? Beryllium belongs to group 2 on the periodic table, group 2. So it will possess a plus 2 charge. You see that now. Then boron belongs to group 3. It will possess a 3 plus charge. See that now? Then carbon belongs to group 4. But here's the thing. Though it belongs to group 4, so we're supposed to say carbon has a plus 4 charge, isn't it? But carbon is considered unreactive. And since it is unreactive, it will possess no charge. So that's 0. That's 0 for carbon. So 0 for carbon. So though it belongs to group 4 but possesses no charge. So the nitrogen belongs to what group? Nitrogen belongs to group 5. And you see, right? Element that belongs to group 5 always possess a -3 charge, because I told you it belongs to group 5. It does not mean possess a +5 charge because it's a -3 charge. Now that is it for nitrogen. So the group 5 element. Oxygen belongs to group 6. It does not possess a +6 charge. It possesses a minus or 2 minus charge or -2 charge. So that is how it works. Then fluorine belongs to fluorine belongs to group 7. That's called the halogens. Remember, halogens are called the salt formers. That is what halogens mean. So it belongs to group 7, but it possesses a -1 charge. And to write -1, you don't write -1 like this. No, you only put the minus that shows it carries, it's just -1. So -1 or +1 thereabout. Then neon belongs to group 8, and group 8 you see, alright, they're called the noble gas, group 8 or group 0. So for that reason, neon carries no charge. The charge for neon is 0. Then talking about sodium belongs to group 1. See that now? I guess you know what charge it carries, right? It carries a +1 charge. +1 charge. +1 charge. Sorry? +1 should be written like this. You see that now? So you don't have to write +1. Then magnesium belongs to group 2. It carries a +2 charge or 2 plus charge. Aluminum belongs to group 3. It carries a +3 charge. You see that now? So you designate the charges based on the group they belong. Now that is it for that. Silicon belongs to group 4. All right. You see, silicon is supposed to carry a charge, isn't it? But silicon will not carry any charge. Since it skips nitrogen. Okay, given that already. Now, that is it for silicon. Silicon carries no charge, just like carbon. So we've seen 2 elements so far that carry no charge. And I want you to understand what we're doing. One of them is silicon. It carries no charge. The other one is carbon. So it's important you know these two differences. So carbon and silicon, they carry no charge. Then the other sets of elements that carries no charge are the noble gases, and one of them being helium. I'll talk about this when I'm done with the first 20 elements. Now let's talk about phosphorus. Now phosphorus now belongs to group 5. You see that now? Phosphorus belongs to group 5. Then group 5 elements are known to carry a 3 minus charge or a minus 3 charge. Another group of elements we saw, remember, was nitrogen. Don't forget that, nitrogen. Now, sulfur belongs to group 6. And you know group 6 elements, just like oxygen, like we talked about before, we always carry a minus 2 charge. So sulfur here will carry 2 minus charge. Then chlorine belongs to group 7. Alright, you know about that. And group 7 element carry a minus 1 charge. So you write minus like that, you don't have to put minus and 1. No. And argon is a noble gas. It belongs to group 8 or 0. And these elements are known to carry no charge. So argon possesses no charge practically. Then potassium belongs to group 1. Alright, so as you already know, group 1 element carry minus 1 charge. Calcium belongs to group 2, and I believe you can guess that. Carries a 2 plus charge. Now, let me summarize something important for you. So, I made mention of silicon and carbon. These are the two non-noble gases or non-group 8 element that carries no charge. Carbon, like we mentioned here, then silicon. Now, the other set of element that carries no charge are called the noble gases, and let me highlight them with a different pen color for you. Helium is one of such, carries no charge. Know this. Another one that is a noble gas that carries no charge is neon. You see that now? Yes, carries no charge. Then the other noble gas that carries no charge is argon. You see. So in total, for the first 20 elements, we've seen 5 elements that carry no charge. 3 of which are the noble gases, and 2, the other 2 are carbon and silicon. So these are them. So you may be wondering what the noble gases are. I'll talk more about the noble gases when I create a video on the periodic table. Now, having done that, I believe the charges are clear right now. We want to go straight right into the mass numbers. How can we get mass numbers? That's also another challenging part for most people. But I will help you break that down. To get the mass number of hydrogen or of any elements, you have to ask yourself, am I dealing with atomic numbers? Like, am I dealing with odd numbers, or even numbers? I believe you know from mathematics that odd numbers are numbers that when you divide them by 2, they'll leave the remainder. But even numbers are numbers that when they are divided by 2, they leave no remainder. So this is the difference between odd and even numbers. So I believe I've been able to help you demystify that. Now, let me talk about them. We're going to work with them right now and see what we have. If the atomic number is an odd number, then we have to multiply that atomic number by 2 and add 1. I repeat, if the atomic number in question is an odd number, all we've got to do is to multiply that atomic number by 2 and add 1. But if the atomic number in question is an even number, we have to multiply by 2 with no inclusion of 1. So it means for even we don't add 1, for odd we add 1. Now let's practicalize what I just said. However, let me clear the air before I move into this. However, there are few exceptions. There are few elements among this top 20 rather, that don't follow this rule I just said. One of the elements that does not follow this rule is nitrogen. The other one that doesn't follow this rule is hydrogen. And the other one that doesn't follow this rule is chlorine. And I'll show you why they don't follow the rule. For example, now, hydrogen is plus 1, right? So if we're to follow the rule, I just give you 1 is an odd number, so we're supposed to multiply 1 by 2 and add 1 to make it 3, right? Yes, but that would work. The mass number of hydrogen is fixed, and it is 1. Mass number of hydrogen is 1. Now, helium, of course, follow the rule. Helium is carrying an atomic number of 2. So 2 is an even number, so all we've got to do is to multiply 2 by 2 to get 4, so the mass number of helium is 4. Then lithium is 3, number 3. So 3, is an odd number, and so we have to multiply that 3 by 2 and add 1 to it. So lithium becomes 3 times 2, and that gives me 7 as a mass number of lithium. So beryllium is 4. And of course, 4 is an odd number. So it's an even number. So multiply 4 by 2, that gives us 8. So the mass number of beryllium is 8. Or sometimes it can be 9. So 8 or 9. Whichever one you use, you'll get almost the same answer when you solve it. Now, boron, you see, is 5. That's the fifth element. So the atomic number is 5. And of course, 5 is an odd number. So we have to multiply 5 by 2 and add 1. So if we do that, we'll get 5 times, so that's 10 plus 1. The mass number for boron becomes 11. Well, there are sometimes it can be 10, it's possible. You see that now? That is it. But the first one is perfect. Now, I've done the first 5 for you based on the rule I just gave you. Can you pause the video, then solve from number 6, the 6th element, down to the 20th element? Go ahead. Alright. Now, let me do that. Carbon is the 6th element, and 6 is an odd number, is an even number. So all we have to do here to get a mass number is to multiply 6 by 2 and add 6 by 2 only. So 6 by 2 gives us 12. Nitrogen, I told you, is an exception here. Alright? Since nitrogen is an exception, we can't follow the rule. Now, suppose we were to follow the rule, it would have been 7. 7 is an odd number. 7 times 2 gives us 14. Then we'll add 1 to make it 15. But no, nitrogen has a fixed mass number of 14. So we've seen exception number 1. Then hydrogen is exception number 2. You see that now? And chlorine, then every other one follow the rule. Oxygen, see that now, is the 8th element. So 8 is an even number. 8 times 2 gives us 16 as the mass number of oxygen. So fluorine is the 9th element. 9 is an odd number. 9 times 2 gives us 18 plus 1, 19. The mass number of fluorine is 19. Neon is an even number. You see that now? So neon is an even number. So we're not going to add 1 after multiplying. So 10 times 2 gives us 20, and that's all. No addition of 1. Sodium is the 11th element. So 11 is an odd number. 11 times 2 gives us 22. We're adding 1 because sodium is an odd number. So 11 times 2 plus 1, that is 23. Then magnesium here is the 12th element. 12, of course, is an even number. 12 times 2 gives us 24. No inclusion of 1. Aluminum is the 13th element. And of course, that 13 is an odd number. 13 times 2 gives us 26. Then adding 1 gives us 27. Silicon here is the 14th element. You see, 14 is an even number, so we're going to multiply that by 2. 14 times 2 gives us 28. Phosphorus, 15, is an odd number, so 15 times 2 gives us 30, and we're adding 1 because it's odd. That's 31. Sulfur here is even number, 16. 16 times 2 gives us 32. Chlorine is an odd number. 17 times 2 gives us 35. 34 plus 1, 35. But hold on, I told you chlorine is another exception. So if we were to follow the rule for chlorine, we would have gotten 17 times 2, which is 34 plus 1, 35. But chlorine has 2 fixed mass numbers. One of them being 35.5, which is more common, and the second one being 37. So chlorine is an exception that does not follow the rule. Argon is the 18th element. 18, of course, is an even number. 18 times 2 is 36. See that now? Potassium is 19. 19 is an odd number. 19 times 2 gives us 38 plus 1. That's 39. Now, calcium is an odd number, an even number, beg your pardon. So that's 20, right? 20 times 2, that gives us 40. So guys, this is it. I tried as much as possible not to make the video too long. So the first 20 elements, the charges, the mass numbers of the first 20 is done in 20 minutes. What a coincidence. Alright guys, exactly 20 minutes. So we're done with this video. I believe you enjoyed the video. Please share with your friends and your siblings who may find it helpful. Like the video, subscribe, and see you on the next one.